Let's talk about comparing values. So this is something like, is one value greater than another? And we can do this by dropping a empty box and typing in the greater than symbol, pressing enter, and we end up with a comparator that is one value greater than another. And it's just worth pointing out that you can also get to this from your instructions palette here. So open the instructions tab and then come down to comparator operations. And here we have all of the different types of comparisons that we can do on variables. So I've just put down one of these, but you can quite easily drag in something like an equals and drop that onto your network, and you have the same thing here. Or alternatively, what you can do is just double click and change it here. Now we have the same thing that we saw on the maths instructions, which is these question marks. If I double click here, here are all of the different data types that can be compared. But if you leave it as question marks and TIA Portal is capable of detecting what you're doing, it will change it to the most appropriate data type. So for example, if I compare from my numbers data block, I1, it changes to int immediately. And I'm going to compare that with numbers I2. This is treated as a boolean output. So you'll notice that it doesn't look the same as the previous numerical instructions that we've done for add and move. It actually is a digital output or a boolean output. So we have preceding logic in 0 or 1, and then it outputs a 0 or 1 on the same line that normal boolean instructions work with, which is why I can't just download this as it is, because we need to have an instruction at the end. So I'm going to set a coil, and the coil will be bools B1, and I can download this. And from our previous lessons, we can see that we have a value of 1 in here and 21 in I2, which is not greater than. But if I change this value to 25, we're now greater than, and therefore B1 is set to true. If I change this to less than and download to the PLC, we can now see that B1 goes false because 25 is not greater than 21. So let's have a look at some of the other types of comparators. Here we have a equals, so we only pass a logical 1 if the top number equals the bottom number. So if I change this to 21, we now pass true and B1 gets set to true. In contrast to that, if I set this symbol here, which is not equal to, then anytime the numbers equal each other, we pass false, but any other time we pass true. So if I now set this back to 25, because they don't equal the same, we now pass a true and B1 gets set to true. And we also have a combination of greater than or equal to, which compares the top and the bottom. And if the top is greater than or equal to the bottom number, then we output a logical 1. So in this case, 25 is greater than 21. And if I set this to 21, it remains true. But as soon as I go to 20, we're no longer true, and B1 gets set to false. So in addition to the basic comparators that we've seen here, that all are prefixed with CMP, we also have these ones down here, which is in range, out of range, and some validity checks, which I've never really had any use for, but I can see why they're considered comparators. So this is just checking if it's a valid floating point number for reals. But at this point, you're most likely to use something like in range or out of range. So let's have a look at what an in range looks like. And if I put on here numbers I1, numbers I2, and in the middle we'll put numbers I5. And we'll just delete this here and send this down to the PLC. And what this is doing now is checking, is 6 the value that's on the value input? Is it between min and max, or 20 and 21? And the answer is no, it's not. So we don't have a logical true coming out. We have a false, which is setting B1 to false. If I change this to 20, you can see that we're now in range because it's inclusive. And if I set it to 21, it remains in range because both of these are inclusive. But if I change this one to 10, this one to 20, we can see that we are no longer in the range because the range window is 10 to 20. We're set to 21, so it drops off. And you can do this with comparators. You don't have to do it this way. If we were to demonstrate that with a branch, I can drop 2 comparators down, set this one to greater or equal to, and this one to less than or equal to. I can plug the same numbers in, so I1 and I2, and then put I5 on the top of both of these, connect that up, send it to the PLC, and effectively we have exactly the same check. But this one is a instruction, and this one is made up of individual instructions. And if I set this to 15, we can see that both of them end up with a logical true. So there's no real advantage to using this way. I think it's just a little bit more visual and obvious on what you're doing. There's less room for mistakes because you're only defining variables sort of once on the interface. You have to do it again for this approach. But they take up the same amount of space because this actually takes up 2 instructions worth of space. And yeah, they do exactly the same thing. So it's really down to personal preference. The nice thing about in range is you can double click there and change it to out of range if you want to. But again, that's not something that you can do in runtime. So it's still down to personal preference.